this lesson will give an intro to limits examples. Write in limit notation, f of x approaches 3 as x approaches 7. We would write this as limit, here x approaches 7 f of x, and this will equal 3. What do these two limits mean? What we have here, this says that the limit as x approaches 3 from the right equals 10, and the limit as x approaches 3 from the left is 5. Let's make a graph of something that satisfies these two equations. So we have x equals 3 here, and let's say that we have 5 and 10. So we know that as we're approaching from the right, we have the function approaching 10. So we can draw something like this, and it doesn't matter what squiggles we have over there. And then, as we approach from the left, we have f of x approaches 5. So maybe that could look something like this. Here we're just going to analyze some limits in a very, very complicated graph. So let's look at points denoted by all of these blue lines. At this blue line, we can estimate the limit as x approaches this point to be about 0, because it looks like that's what the y value is here. At this point, as x approaches from the left, we can estimate it to be at about 1, but as x approaches from the right, we would get an answer of about 2 to 3. So in this case, we have that the limit does not exist, because the limit from the left and the right are not the same. Now, as we go through, at the origin, we can estimate the limit as x approaches this point to be about -5. And then at this point right here, where our graph jumps, the limit from the left is about -6, and the limit from the right is about -2. And so here again, since the limits from the two different sides are unequal, we have a limit that does not exist. Now, at this point here, we have a vertical asymptote. So as x approaches this point, f of x approaches -infinity from the left, but if we're coming from the right, then we have f of x approaching infinity. So again, we have a limit that does not exist. And finally, at, say, a random blue point right here, we can estimate that the limit as x approaches this point is about 2, because that looks like that's where the y is. Draw a function for which the following limits hold true. Okay, so I'll just start here. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm labeling the points for which I'm given information about the limits. So now I can start with, I know that when x approaches 3, then I have y approaching 4. So label that as 4. Maybe we can have something that looks somewhat like this in this area. Okay. Then I know that if I approach 0 from the left, then I end up with a point near -1. So that can look something like this, approaching from the left. And if I approach from the right, then I end up with a function near 3. So maybe that can look like this. And let's just have it hook up to whatever I've already drawn here. Okay. And then as I approach 10, I get close to infinity. So that would be something like we have a vertical asymptote here, and as we approach, we get infinitely larger, and it has to be the same from the other side because I know that the limit is the same from both sides. So on this side also we have the asymptote. And then we're not given any information about what happens in between here, so I'll just connect it randomly like this. And so now we have a function that satisfies all of these limits.